This year, governments have laid out some of the most ambitious environmental targets we've ever seen. Boris Johnson's UK government has enshrined a pledge into law to cut emissions by 78% by 2035. And the Biden administration has pledged to cut emissions by over 50% of 2005 levels by 2030. And industry leaders have been signing up to pacts left, right, and centre.
The great thing about pacts is that gets the initial momentum by the leaders to say, in fact, this is possible, and even for the challenges we don't know how to solve yet, we'll come together in collaboration to find the answers to these challenges.
While innovators get together to find solutions to the big challenges, today on the show we're going to be looking at energy and innovation through the lens of organisations, from tech to people to buildings. We'll be finding out which technologies can make us more efficient today, how to get to grips with managing disparate legacy assets, and whether dropping a data centre in the ocean is a viable solution. All that and much more. I'm Michael Bird, and this is Technology Untangled. When we look at the big picture, it's clear that producing and using more renewable energy is a fundamental target for tackling climate change. So to set the scene, I asked HPE Chief Technologist Ian Henderson to help us understand where we are with energy today.
I think the UK has actually made pretty good progress. Got a long way to go, but I think we've done a lot in reducing the level of fossil fuels, but we're still having to make a significant investment in nuclear, quite controversially. And there are big changes afoot, with stopping new house builds having gas boilers and moving to new technology like air source or ground source heat pumps. Not so easy to retrofit that, as I found looking at it recently. So there's a lot that we are doing with solar farms, with investment in wind, but there's a challenge to store that energy sometimes.
Why is that?
It's very expensive to store energy at scale, right? So I worked with the National Grid over the years, and I remember going to see their facility down near Reading. They said, it's difficult to store, but we've got a big battery. So their big battery is a hydroelectric plant in Wales. And what they do there is when the electricity is at a peak, when we used to watch the Bond movie and go and put the kettle on in the advert break, and they need suddenly, a huge amount of extra energy, they can release the energy from the reservoir at the top of the hill and generate within a few tens of seconds, I think, a huge amount of energy. But it only lasts as long as the water in the reservoir. So how is that a battery? Well, what they do when the energy is cheap at night, or cheaper, is they pump the water back up again, and they're storing that energy as potential energy to be released again by dropping it back down through the turbines. So a battery in the sense of storing energy, but not the way that you would expect it to be. And there's a huge investment now in electric vehicle technologies, and particularly the batteries. So the cost of batteries has come down, the density of them's gone up. We can have a battery in our home that can store energy generated from solar panels. Elon Musk has done this stuff in Australia. It's probably the biggest project, where he built them a 100 megawatt battery plant in 2016, 17 in just 60 days. And I think they're now building one that's 3 times the size, 300 megawatts, that will store solar and wind generated energy and saving them hundreds of millions of dollars in transmission network cost.
Why don't companies who've got massive tower blocks store energy in that way? Pump water up to the top of this, the Burj Khalifa, and drop it down when they need it.
I suppose you could. These things cost, even the facility in Wales, they cost an awful lot of money to build. It's a huge civil engineering project. You could probably generate some by doing that in a building. There are people looking at creative ways of how do we generate and store electricity from energy that's just being wasted.
There are lots of organisations across the world looking at weird and wonderful ways to solve the energy problem. Although I will be patenting that Burj Khalifa thing, so hands off, Elon. Anyway, speaking of patents,
One of the things that we recognize is that climate change is one of the greatest threats to our common future, and the world doesn't have all the technology solutions that it needs.
That's John Frey, HPE Chief Technologist for Sustainable Transformation. When we spoke, HPE, Microsoft and Facebook had just announced the Low Carbon Patent Pledge, which opens up patents for innovators to iterate on them.
Some of them were really interesting lines of research that, frankly, we as HPE or Microsoft or Facebook decided perhaps not to pursue, but that might be very valuable and useful in the space of the low carbon economy. And because we have a need to accelerate this innovation cycle, opening up these patents to others to innovate are one way of accelerating that.
What kinds of organizations do you think, or I guess individuals, would take advantage of this, make use of the patents?
Yeah, there's a lot of tech incubators out there. Some of them are now focusing on climate, or I don't like the term personally, but they call themselves green incubators. For example, if they're looking at how do you build technology to bank energy when the sun's not shining or the wind's not blowing. We've done some work with fuel cells there that open some really interesting doors in that regard. Or it might even be larger companies that have said, hey, we're not a technology company. They're really great at designing, for example, a new efficient solar panel. But how do you do load balancing to take advantage of the amount of energy capacity that comes out of the solar cell? So there's a variety of patents that we think have pretty broad applicability. And we're delighted to see what folks are going to come up with to take these patents and extend that innovation.
So while the innovators are innovating, organizations want to know what they can do right now. Way back on our episode on the circular economy, you may remember Matteo Dugan.
There is a scientific fact which says that the IT industry is today responsible for close to 4% of the greenhouse gas emissions on Earth.
We look to tech for answers. Think using supercomputers for climate modelling. But there is a balance that needs to be struck.
One of the things that we find is technology can be a force multiplier as it relates to climate change. So as we use technology to really drive climate impact forward, its use of power goes up at the same time that the world's trying to decarbonize all around it. So if that's happening, we've got to use technology responsibly, and we have to make sure that our technology is being used efficiently.
Okay, well, let's go there. Efficiency in IT, the data center to be precise. Our global technology needs are only increasing, and that means data centers are using a heck of a lot more power. Ian Henderson explains more.
There's many components that use a lot of energy. We have processors today that can be, over 200 watts, memory, increasingly GPU, so it's actually possible with some of the machine learning platforms that we've got to generate many kilowatts of energy consumption. A lot of the challenge here with the technology we're using is that power isn't doing useful work. Lots of components, but increasing in density.
Where does cooling fit into that in terms of the energy usage?
There's a lot of ways that the energy is wasted. So cooling, applies in a number of different ways. So we have this measure that we use called PUE, or power usage effectiveness, which looks at the ratio of how much energy is used for useful compute versus actually running the entire data center. So things like air conditioning, power conversion, there are losses in many different areas. So a typical data center that you might have looked at 10 years or so ago would often have a PUE of 3. Right? So that meant for every watt that you used for compute, you were using 3 watts of energy to convert that power to do the cooling. So a lot of wasted energy in that sort of space. There's a lot being done to try and drive that. And in the very best case, you can get close to a PUE of 1, where every watt of energy is used by the computer. Now, that doesn't mean it's used to do useful work.
So why don't they just put data centers, why don't they just drop them in the ocean or put them in very cold climates so they don't need to be cooled?
So they can, and I think Microsoft have got a project a little bit like that. I think certainly in countries like Iceland, they're doing some good stuff there where they're using the low ambient temperature outside to help with cooling, and also geothermal energy being produced. But that's balanced with the communications challenges of a remote location like that. I think a good example of building best practice was actually DXC. They built a new data center in the north of England, in Wynyard. They built it in the north of England, sucked cold air off the North Sea, harvested rainwater, used the energy that was generated to heat the building space and things like that. So that can be done at a smaller scale as well, actually, because what we've got now, rather than trying to modernize a data center or build a modern data center, we work with partners where we can drop in a containerized data center. So actually Mercedes Formula One that I work with have that. So they, about 18 months ago now, I think, bought a new data center that would take, I think, about 30 racks, something like that. And that came in and was optimized.
Trust me when I say that it was a challenge not to go off on so many tangents around sports cars, underwater data centers, and new experiments in cooling technology. Although maybe that last one we'll be talking about a bit more on our episode around quantum computing. Anyway, unless you're in manufacturing, IT might be your biggest consumer of power. And to get a handle on that, you need a bit of a strategy. John Frey suggests 4 key metrics for efficiency.
The first is equipment efficiency. If you have a piece of equipment in the infrastructure, make sure that piece of equipment is doing the most amount of work possible so that it takes the fewest pieces of equipment to implement the solution. Then electrical efficiency. How do we make sure that if we have a piece of IT equipment or a piece of building infrastructure equipment, that it consumes the least amount of energy necessary for the workload? Third is resource efficiency. We know, for example, that the average data center has 2.5 times the cooling capability it needs for the load that's in the building. So how do you make sure, whether it's power conversion, whether it's backup power, whether it's cooling systems, that the quantity is optimized to the load and you don't have more than that, so that we're saving energy even in that resource side of the equation? And finally, and this is quite frankly the toughest one, software efficiency. So many times when I talk to computer science and computer engineering students around the globe and I ask, you're designing code, you're designing hardware, have you been taught to design in optimization in your software? And they say no. And yet we know that efficient code that saves compute cycles can reduce energy. And at the same time, software can be used to automate processes, because when you have that software-based automation and efficiency attributes built in, systems can start self-optimizing. If you have a lower workload, the system can go into a lower power state.
To bring down the amount of energy we use, renewable or not, we need to address the elephant in the room. All of that idling equipment.
When we look at studies of data centers around the world, what we find is about 25% of the equipment in the average data center is powered up and running, but doing no useful work. And then if you look at that other 75%, it's being operated down in the 10 to 30% of its rated capacity. And let's be clear, IT loads are typically not static. They vary by time of day. They vary by day of the month. If you're someone that is processing bills to your customers, for example, the end of the billing cycle is a huge technology spike. So there are reasons that equipment may be idle for short periods of time, but it's really inefficient to have that idling going on for significant portions of the month.
So, what can you do? Well, one option is switching the way that we procure technology and considering a consumption model.
The historical approach that we had many years ago was a project would buy equipment for itself. We'd do this estimating of sizing and they'd buy the capacity up front. That's hugely inefficient in the way that you do that. Whereas if you look at the consumption-based model, we can drop the right sort of amount of equipment onto that site. The customer only pays for what they use. We monitor the consumption and we backfill that consumption ahead of them needing it.
If you want to know more about consumption models, you can go and listen to episode 2 of series 1 on everything as a service. For the kit that's already in the data center, we're seeing some interesting moves in the automation space.
One of the things that automation brings to the table is it allows you to see those inefficiencies in real time. It also helps customers solve the typical problems they run into in a data center, which is they run out of space, they run out of power, and or they run out of cooling. And if you take that equipment that's not providing useful work to you out of the infrastructure, all of a sudden you've solved space, power, and cooling issues. You've significantly reduced both CapEx and OpEx expenses. And then when we talk about PUE, it allows you to not only see the efficiency of the IT stack, but it connects that to the efficiency of the building cooling systems and the power conversion systems. And that allows you to see the entire infrastructure from an efficiency perspective together.
Having good visibility across infrastructure is really important. And Ian believes it can also help to bridge the gap between energy use in IT and energy use across the rest of the organisation.
I've seen so many IT teams who don't really consider the energy cost and that it's handled by facilities teams. And I remember one project where I spent a lot of time looking at how we could consolidate all of their computer systems down. So I'd looked at levels of utilisation, all of the application estate, what was the energy consumption, what was the physical footprint of all of the hardware. And I calculated over £1 million a year in energy saving. Right. And I was so pleased. And I went back in with this business case for the customer around data center footprint savings, energy saving. And the big ticket item was this £1 million plus. I think it was about £1.5 million a year. And the customer asked me to remove it from the business case, because the facilities team paid for the energy, he didn't. And he didn't want their attention drawn to how much of the energy was used by IT. And I've seen that more times than I care to remember. So I think what we need to look at is how we run the data center efficiently and manage it by understanding the utilization, reporting on that, using technologies to optimize the amount of IT that we're using and bring that consumption down. So PUE is important, right? It's important to run it efficiently. But if we can use technologies like virtualization to drive that utilization of the equipment up, okay, and I think that then comes into some of the consumption-based models. So I think it's a cultural, organizational challenge where they've got to take responsibility for not just the energy consumption, but the whole IT consumption.
So for IT and the data center, the best practice now is energy efficiency. Automation and consumption models are some of the leading trends that can drive that, but it has to feed into a wider organizational strategy. But that's just part of the picture. After all, our organizations are not just IT alone. So what's going on in our buildings?
We've done some work using our Aruba technologies to very, very simply add additional sensors for temperature, humidity, those sorts of things, to give you a finer grain view of how the building's being used, what energy is being used by the building, how many people are there, those sorts of things. And it's, how do I fine tune and control that? And we've seen that at home. Many of us have got Hive or Nest sensors for our home heating, right, that can monitor and adjust the temperature of the home, if you think of being able to do that on a larger scale across a building.
And that's exactly what I did want to think about. So I called up somebody who's investigating just that.
I'm Rasha Hasaneen. I work at Trane Technologies, and I'm currently the Vice President of Innovation and the Executive Director for the Center for Healthy and Efficient Spaces.
Trane Technologies work with all things IEQ. But what's IEQ?
So indoor environmental quality, it's sort of an industry term. It lines up a lot with the sustainability language that you would see in like a LEED program for buildings, but it consists of 4 big pillars. The first is thermal comfort, so how cold or hot you are. The second is air quality, so how good is the quality of the air you breathe? And is it appropriate for what you're trying to accomplish, learning, productivity, or working, sleeping, etc.? There's lighting, and there's been a lot of development recently around the color and temperature of light and how it lines up with your circadian rhythm. And lighting is part of a bigger category called visual comfort, which takes into account things like, are you able to see the outside in? Are there water views? So there's been a lot of social science around What is it that is a healthy visual environment? And then the fourth big pillar is really noise and acoustics. And there's been a lot of studies that have shown that high levels of different types of ambient noise can degrade learning, it can degrade productivity. Noise has a huge impact on our ability to function.
Even though you might not know it by name, we have been talking a lot about indoor environmental quality a lot recently.
Healthy and efficient spaces, indoor environmental quality, and that intersection with sustainability has been around for a long time, but hasn't been a huge focus. So there's been a lot of research over the years, sort of here and there, but because it's not something you can see and feel and touch, it hasn't historically been a huge priority for people, whether in their homes or in public places. When the pandemic hit, it became clear that indoor spaces have a huge role to play in pathogen transmission. And all of a sudden it became new again. But also, if you remember early on in the pandemic, there were some studies that came out that showed that if you had too high humidity, too low humidity, or high particulate matter, dust in the air, it would increase not only the transmission of the pathogen, which scientifically makes sense because it can ride on more things, but it also increases the severity if you were to contract the virus, how severe it was. And that has a lot to do with these types of things impact on sort of your lungs and your health. So that's kind of what's put it in sharp relief. But we've known indoor air quality can be tuned for healthy spaces for a long time. So there have been studies for over 20 years that have shown that having the right level of indoor air quality could have as much an impact on the test scores of students as GPA. So when you're trying to predict how well a student does on a public exam, you use a lot of indicators. GPA is one. It's hey, if they have a high average throughout their schooling, they're likely to have a much higher test score. Well, they found poor air quality or good air quality has a higher correlation to whether or not they're scoring on the test. And these are peer-reviewed studies. I'm not making this up, but this is the type of thing where you're well, these studies have been here, but because you can't see, feel, touch air, we tend to not pay as much attention.
The science on indoor air quality and productivity is well documented, and we'll link some studies up in the show notes. But it's not hard to imagine how those productivity costs would ultimately affect the business bottom line.
Things like employee productivity, reduction of sick days, has a huge impact on the profitability of that business. You're making your employees healthier, and you see a lot more employers today investing in health programs or preventative health programs for their employees, but these are soft costs. So it's very hard to trace.
The pandemic has made controlling indoor air quality a really important thing for organisations. And Rasha and the team want us to get precise by measuring everything from particulate matter, volatile organic compounds, carbon dioxide, carbon monoxide, humidity, temperature, the list goes on. And if your office has got a bad air quality, you obviously want to get more air in. But the issues are around how you do that.
So you can control that by having a ventilator as part of your HVAC system, or you can open a window. Opening a window is uncontrolled. What that does is it requires more energy to condition that outside air, because now you're bringing in air at whatever the ambient temperature is to improve the air quality. And so the more outside air you bring in, the more energy you consume, which goes against where buildings have been going, which is to have a tighter and tighter envelope to improve energy efficiency. So now you've got to come up with creative solutions that allow you to clean the air you're circulating in a way that allows you to save energy. In addition, you want to start to recover energy from outgoing air to transfer to incoming air. There's a lot of different techniques you can use, but if you're optimizing for air quality and energy together, you're going to have a better outcome than if you're just optimizing for air quality. The other piece of this is when you start to look at the intersection of now thermal, air quality, and lighting and noise, you start to have an opportunity to optimize across those things. So for example, when you go from incandescent lights to LED lights, incandescent lights produce heat. LED lights, they don't. When you go to LED, you don't have as much heat coming off the light bulb, so you don't need as much cooling. By thinking about the system holistically and then really putting in, what I would call like edge optimization type software, start to really think about, when we think about the Internet of Things, right? You now have a really interesting way to get both high quality indoor environments and energy efficient buildings.
When we talk about controlling indoor environments, whether that's our home or in our office, we come across the same challenge that John Frey discussed. We bring in tech to solve a problem, but that then can sometimes create more problems. And that's something that Rasha and the team are acutely aware of.
It's a vicious cycle, right? It's too hot, there's too many particulates, it's bad air quality, there's smog. Okay, great. Ambient air quality is not good. I'm going to go inside and I'm going to put in all these technologies that consume all this energy. And as a result, I'm going to burn more fossil fuels. I'm going to degrade the ambient air quality further. And then I'm going to need stronger and stronger things to filter that stuff out inside. And it becomes this vicious cycle. So we have to bend the curve on this.
To try and solve this cycle for our indoor environments, Rasha's team at the Centre for Healthy and Efficient Spaces has brought together policymakers and academics from scientific fields such as atmospheric sciences and architecture to explain how indoor air quality and sustainability can fit together. And what they're finding is that obvious trade-off that you'd imagine is less than certain.
One of the things we've looked at, in fact, we've published a couple of papers on this, is when you start to optimize for occupant comfort, so you create sort of microclimates around the occupant versus conditioning entire zones, you can actually create higher energy efficiency by virtue of focusing on the occupant. You're not trying to get to a better energy efficiency. The outcome is better energy efficiency. So bringing in outside air, ventilating, filtering, traditional approaches, you're having to find energy savings elsewhere to compensate for the air quality. I do believe that with innovation in this space, there will be solutions that come out that don't require that allow you to have both without any compromise. And that's where we're focusing our energy.
Through cross-industry collaboration, Rasha and the team are looking to solve the efficiency challenges of our built environment. And if you want to hear more about innovation in this space, you can check out Rasha's podcast, Healthy Spaces with Trane Technologies. But Rasha mentioned IoT, and I wanted to follow that thread a little bit more, because right now, our offices and commercial buildings are made up of a ton of assets, many of which are old and pretty difficult to manage.
Buildings are pretty crudely controlled. Air conditioning might be on a timer. You might have movement detectors that turn lights on and off in an office building, but I don't think that's very often captured and reported. There isn't the visibility to understand how is the building being used? How many people are there? Can I adjust the cooling? Connecting into the existing air conditioning, using sensors like video to understand how busy the building is, to put a few extra sensors out there.
And adding a load of sensors doesn't necessarily immediately translate to energy savings.
I think the challenge with that data today is it's lots of different silos. So there probably isn't connectivity today between the heating system, the lighting system, the Wi-Fi or CCTV that tells us how the building's being used. So pulling that together into one platform and then being able to do analysis on it should be able to bring a lot of efficiency and energy consumption.
As with our IT, having visibility over all of our assets is hugely important. But how can we pull all of that data together? And is that even possible for every organisation? Luckily, I knew just who to speak to.
My name is Jordan Appleson. I'm the CEO of Hark, technology business specialising in energy analytics and industrial IoT.
Hark are specialised in helping organisations achieve the perfect trifecta: increased efficiency, maximise yield, and reduced waste.
What we do is we connect to industrial assets, energy meters, building management systems. We monitor the sensor data, so it could be real-time energy data, temperature data from assets, process data in real time. And then what we do with that is help our customers analyze it, report on it, alert, and then in the cases for more advanced customers, automatically control assets based on things like predictions and operations.
In 2017, Hark were approached by one of the UK's leading supermarket chains, who have over 1,000 sites to help them gain visibility of their assets.
The primary goal of this project was initially energy, real-time energy data at an asset level, not just at a building level. So to do that, in the case of, say, a supermarket with hundreds of sites across the UK and Ireland in this case, you've got a lot of different types of assets, right? Old assets, legacy assets, new assets. Sites are of different ages. So the key area of that was trying to standardize on a way of connecting to assets that were old, and technology companies saying, no, you're going to have to replace them with the latest and greatest. And our scenario was like, no, they're working. It's expensive to replace them. Let's retrofit in a way that's scalable, and then use that for kind of intelligent monitoring and control in the future, which is where we are today.
Jordan was faced with what he describes as a pretty typical situation. Lots and lots of disparate legacy assets. To make the business case, they decided to do a cost-effective pilot, focusing on the worst store with the oldest assets.
They'd had people tell them it was impossible to do it, and we kind of said, look, just to demonstrate the point, using our technology, give us half an hour and a Raspberry Pi, and we'll go and use a Raspberry Pi to demonstrate that this is possible using our software technology. Now, of course, we don't use Raspberry Pis for real deployment, but from a cost-effective perspective, to demonstrate the point as quickly, it's not just possible, it's kind of plug and play. We did that, and it's like, right, here's the box on the wall, here's 2 wires connected to this, here's our platform, here's another 2 wires from this HVAC system. Here you've got real-time energy data for 40 assets now, and here's your HVAC system's control set points, etc., etc. So you do that one site, you start to look at the intricacies of deploying that at scale, and you start with, say, 5 and then 20, and then you roll out to the whole state. It's the typical way of working in these scenarios. And then you've got to think about networking and the hardware that you use, right? Like the gateways and then the cloud technology that sits behind it. But we already had all of that, so it was quite really easy to just spin it up and go.
The supermarket's assets ranged from fridges to bakery ovens, coffee shops to petrol forecourts. And as we discussed with the data center, maintenance also plays a part. Because if your assets aren't running at an optimal level, they're basically wasting energy too. Measuring all of that requires a huge amount of data. So how do they do it?
We started off with energy submeters. So these are very much like energy meters. And for us, there were already kind of existing submeters there. So maybe 40, 30 to 40, each individually monitoring assets at a level. So it could be lighting, and it could be the bakery, it could be the refrigeration systems. So you can get a real feel for how the assets are performing. Now, normally, in historically, our customers would be collecting that data, consumption data, every half an hour. Now, that's useful for reporting and some form benchmarking to a certain degree. But what we then did is take that data that was already available on those meters, but the connectivity infrastructure wasn't really there, and start to stream instantaneous power. So kilowatts, how many kilowatts am I drawing from the grid right now? Voltage information, frequency, obviously consumption, but obviously at this point it's every minute. So we can then build up a very granular profile at an asset level, which we can then use to train things like machine learning models to be very accurate on forward forecasting, and therefore be used for control mechanisms in the future. So the energy piece kind of unlocked a lot for us, because it allows us to kind of benchmark things like assets, like lighting systems that we're connected to. So we're also connected to building management systems that are in control of lights. When I don't mean just off and on, I mean, we've got occupancy sensors, lux sensors. They go, from between kind of 0% and 100%. When we were doing testing, we were trying to get a whole store to flash the lights to Master of Puppets by Metallica, but we only got it working on the bench, and then we thought maybe this isn't a good idea at 4 o'clock in the morning while we're doing our test during closed hours.
Hey, sometimes it's fun to do things because it's just fun, isn't it? So was the end goal saving energy? And what, if that's the case, what were the end results?
Yeah, so the end goal was to effectively, and this the first part of the business case was to save energy. In the first year, from kind of 2019 to 2020, I think we saved about £1 million essentially in that first year. And then I think in terms of the control system, we now have a automatic dynamic control system controlling the building based on things like energy prices and store opening times and even things like occupancy and lux levels, right? That in and of itself is saving about, a similar amount of money, to that first year on a run rate, but also it's saving enough energy to power 300 homes for a year every month, right? It's reducing the amount of carbon going into the atmosphere by something like 50 kilograms per day per store, these kind of things, right? And that becomes tons and tons over time. And that's just in a small subset. So not only is there being commercial benefit, there is also a sustainability benefit. And that will result in a commercial benefit in the future with the way the world is moving towards net zero and policies changing and the cost of carbon being a figure that will end up on people's end of year reports. There'll be a monetary cost to that that's becoming one and the same, really.
So I think you probably answered this question, but for organisations who implement these kinds of things, how long does it take to recoup the costs of implementing it?
Yeah, I think it depends. We're looking for ROI in returns from day one, really, but ultimately within 12 months. The point really as well is you don't know what you don't know. And if you don't have the visibility and you don't have any of this element of measurement technology to actually see what's going on, you can't manage what you can't measure. So we've seen situations where we've deployed our technology and in one site, something's been left on for a year, that's cost £30,000 and no one's noticed. So that ROI was, we've made it all back in literally one alert, right? So it can happen like that.
There is that. Big organisations must have hundreds, thousands of devices that somebody leaves a light on in a room over the weekend or something. And there must just be so much energy wasted with those kinds of things.
Yeah, I mean, the government did a study not long ago and they reckon that, £3.7 billion could be saved across the UK alone just from identifying the waste energy, and that's for businesses, and that 70% of that is retail, industrial, and commercial buildings. I can believe it from what I see with the number of customers we work with, and there are thousands, if not hundreds of thousands of assets. If you look at some of the biggest supermarkets in the UK, and when energy prices start going up even further, because they will, we'll see. Because it's not just energy prices, it's that carbon, it's that sustainability piece, and globally to get to net zero, this isn't going to happen without this technology. If it's not us, it's going to be someone else.
Again, we're seeing that dual strategy of looking at individual assets and considering their role in the entirety of our energy consumption. But IoT is a big space, so I wanted to know what Jordan saw as the most important technologies that organisations need to know about.
So the types of technologies that are going to drive this change are real-time monitoring technology. So gateways, deploying systems, maybe gateways, things that are on site that can actually connect to legacy assets as well, because replacing assets already working is just wasteful, right? So there's a key technology driver there, and more businesses are coming on around that we can't just not connect it, but we can't replace it. And big organizations are saying that. So technologies to connect to these older and legacy assets really easily and get that data into the cloud and into private clouds and into data lakes, massively important. Machine learning models that can make predictions based off historic data that can then enable people to make decisions now before control technology is available, to make really quick action decisions based on these predictions, based on good data. And then you've got the automatic control technology, and that's taking those key technologies, combining them together, and then automatically controlling assets. And that's based on things like energy prices, the operational effectiveness of logistics networks or refrigeration systems. All of this needs to be taken into consideration now, because all this data is siloed, and those silos need to be broken down to be able to then use this technology to effectively reduce waste. And I could talk about this all day because it's so strange. I was saying this, 4 years ago, we started the business, and it's really coming along now. The government, policy, organizations, everyone's got a climate pledge. Everyone's investing. Look at the top 4 supermarkets, they're all investing in climate, billions and billions of pounds.
Energy innovation is a huge topic, and we've been on a whistle-stop tour through just some of the things we can be thinking about as organisations. We've heard a lot of acronyms, PoE, IoT, REQ, AI, but what it comes down to is this: measuring and understanding, reducing consumption, increasing efficiency, and a strategy that considers both the detail and the big picture. There are a lot of financial reasons why we want to get more efficient. However, John says that organisations aren't just thinking about the bottom line. They're looking at energy efficiency because they need to. And in turn, they're turning to tech companies to play their part too.
We're hearing from leadership companies coming to us saying, hey, look, our company has set a 100% renewable energy goal. How can IT help that? And so these are the conversations we have. And the nice part about this is it's the technology industry pivoting because we know we need to, but customers are increasingly demanding this as well. So it gives us a market differentiation. And by the way, the planet benefits.
You've been listening to Technology Untangled. I'm Michael Bird, and a huge thanks to today's guests, John Frey, Ian Henderson, Rasha Hasaneen, and Jordan Appleson. And you can find lots more information about today's topics in the show notes. This episode was written, produced, and edited by Isabel Pollard, with sound design and mixing by Alex Bennett, and production support from Harry Morton, Alex Podmore, and Tom Clark. Technology Untangled is a Lower Street production for Hewlett-Packard Enterprise. Thank you so much for listening, and I'll see you next time.